All right, today we're going to talk about the second part of section 1.7, which deals with composition of functions. Basically, that's when you see this f of g notation. And understand that f of g of x also can be written as f parentheses g of x. So a sample problem that you are going to get is you're given two functions. F of x equals 3x minus 4. G of x equals x squared minus 2x plus 6. So to solve the composition f of g of x, there are three steps. Number one, you want to rewrite it into parenthesis form. So you're going to rewrite it as f parentheses g of x. Step two, you're going to substitute into, or basically you're going to substitute the g of x into the parentheses. So you'll have f parentheses x squared minus 2x plus 6. Step 3, you're going to find f of parentheses x squared minus 2x plus 6. So you're going to take that x squared minus 2x plus 6, and everywhere you see an x here in the f function, you're going to put the x squared minus 2x plus 6. Then you got to put minus 4. Distribute the 3, so you get 3x squared minus 6x plus 18 minus 4. Combine like terms, and you get 3x squared minus 6x plus 14. Final answer. That is your f of g of x. So let's try this on part B, except notice in part B the f and g are switched, which is okay. We just write it g of f of x instead of what we did in part A. And notice the process is still the same, except now we're going to substitute in for the f of x. So we get g of 3x minus 4. That means wherever I see an x in the g function, so it's 3x minus 4 squared minus 2 times 3x minus 4 plus 6. So I FOIL. So notice I get 9x squared minus 24x plus 16 minus 6x plus 8 plus 6. So then when I combine like terms, 24x and 6x gives you minus 30x. 16 plus 8 plus 6 give you 30 as well. So that's your final answer, 9x squared plus, minus 30x plus 30. Part C, notice in part B you found g of f of x. Part C just asks you to basically, what you found in part B, you are now going to find and substitute in a negative 1. So basically, everywhere I see an x, that's not an x, everywhere I see an x, I'm going to put a negative 1. And so negative 1 squared is 1, and 1 times 9 is 9. Negative times negative is positive, plus 30. So notice when I add them all together, I get 69 for my total. So once again, let's do another example. Part A, f of g of x. So then I substitute in. So I get f of x squared, 2x squared minus x minus 1. Then I put that in the f function. So I get 5 times 2x squared minus x minus 1 plus 6. Distribute the 5. 10x squared minus 5x plus 1 is your final answer. Over here, remember it's just the reverse. So I put in the 5x plus 6 for x, or for f of x. Then I substitute this into the g function. So notice 2 times 5x plus 6 squared minus 5x plus 6 minus 1. Foiling over here gives me 25x squared plus 60x plus 36. I'll rearrange that a little bit. Distribute the negative sign, so you get minus 5x minus 6. And then distribute the 2, so you get 50x squared plus 120x plus 72. Then combining like terms, you get 120 minus 5 is positive 115. 72 minus 6 is 66, minus 1 is negative 60, or positive 65. And that is your final answer. So then here in part C, it says basically to put a negative 1 in where you see the x. So 50 times negative 1 squared plus 115 times negative 1 plus 65. Negative 1 squared is 1 times 50 is 50. Negative 1 times 115 is negative 115 plus 65. So 50 minus negative 115 is negative 65 plus 65 is 0. Then moving right along. So now we're talking about the domain of f of g of x. And remember, in our previous section, we talked about things that affect domain like fractions and square roots. Those are the only two things that affect it. If it's not one of those two, then it's all real numbers. Well, to find the domain of f of g of x, you have to also consider the domain of g and the domain of f. And if something does not occur in the domain of g or the domain of f, it does not occur in the domain of f of g of x. So let's do an example here to show you what I'm talking about. So here we're going to find f of g of x. So basically, I substitute in the g of x. So I go 4 over 1 over x, because that's what I'll put here, where I see the x, minus 2. Now I got to get a common denominator. So notice to get a common denominator here, I need the common denominator of x, so I multiply both those by x, so I get 4 over 1 minus 2x over x. Remember, when you're dividing fractions, you multiply by the reciprocal. So the reciprocal of 1 minus 2x over x is x over 1 minus 2x. Multiply across, and that is your f of g of x. Now the domain of f of g of x. Well, f of g of x, remember, is 4x minus over 1 minus 2x. Well, it's easy to figure out what makes the bottom equal to 0 here. If I subtract 1 from both sides, I get negative 2x equals negative 1. Divide by negative 2, and I get x equals 1/2. So that x cannot equal 1/2. That is one restriction on the domain. But you also have to take into consideration the domain of f of x, and f of x is 4 over x minus 2. So that means x cannot equal 2. So that is part of the domain of f of g as well. Also, I have to consider the domain of g of x. And the domain of g of x is that x cannot equal 0. So when I'm talking about the domain of f of g of x, I consider all of these. And to write it as an interval, I basically say that it can be less than 0, between 0 and 1/2, and between 1/2 and 2, and greater than 2. Those are all the intervals that it can be. Now don't forget, you have to put the big U there to mean that you're combining all these intervals. But this is the domain of f of g of x. Last but not least, what we call decomposing functions. Basically, we have h of x here, and we want to know what two functions did you do f of g of x to get this. Well, basically, here's the rule. F of x is the outside function. G of x is the inner function. If you look at this here, inside the square root, you have x squared plus 5. So that is the inner function. The outer function is the square root symbol, so the square root of x. Because think about it this way. If I did f of g of x, well, that would be f of x squared plus 5. And if I put the x squared plus 5 in for x, I get the square root of x squared plus 5, which is what I started with. So therefore, the two functions that compose h of x, the two functions you compose to get h of x are the square root of x and x squared plus 5. Remember, f of x is always the outer function, g of x the inner function. And here's your homework assignment.